Hello again, this is Susan Poss. I'm working in Math 102, Chapter 8, which is the chapter on solving systems of equations. And just as a refresher, a system here, what we're working on are systems that have two variables and two equations, and you know that they are a system. One of the ways you denote that is to use this brace, which indicates that the two equations are to be solved simultaneously. All right, so in the past, the first method that we used was to solve by graphing. We did that back in section 8.1. And we saw that you get a point of intersection, and you get that one solution. Sometimes you get parallel lines, and so you have no solution. And other times you get one line on top of another line, so you have infinitely many shared solutions. So that was our first technique. Our second technique that we're looking at here is to solve by something that's called substitution. Okay, so you're going to see me work 2 or 3 examples using substitution. Here's our first one. You can see that equation number 1 has the two variables x and y. It's actually in what we call standard form. Second equation is solved explicitly for the letter x. That makes this a very good candidate for substitution when you see an equation that already has an x or a y isolated on one side by itself. So what you want to do with this is you want to take let me change color here. You want to take the y plus 4, which is equivalent to the letter x. You want to bring it right over here and replace the x. Let me create a little parentheses there to receive the substitution of y plus 4 in place of the letter x, and thus you see why it's called substitution. Now notice that you have an equation, and this equation only has one variable in it, the variable y. So we are able to solve this. I'm going to use the distributive property. And we talked earlier about how important it is, if you have a little trouble solving equations, to make sure you understand where the left and the right sides are located. So we sometimes put in our little dotted line. I see a couple of like terms here, a 2y and a 3y, both positive. I'm going to go ahead and combine those. Subtract 8 from both sides. And then dividing by this coefficient 5 on both sides, I get y equals 1. All right, so what does that tell us? That tells us that we are going to have one solution, and we already know the y coordinate. Whoops, I don't know what that was. We already know that the y coordinate was 1. So we're halfway there. We've now got to figure out what this missing x coordinate is. All right, so now we're going to do something called back substitution. You can take this answer that you got here that says y is equal to 1. You can take it back either to equation number 1 to sub it in to find x, or you can take it back to equation number 2. I go to whichever one looks easier. And in this case, equation number 2 looks easier for me. So I'm going to take equation number 2, create an opening there with parentheses, and substitute in 1, which is what we found as we solved for y. And when I finish that, then I have finished solving. I now have the ordered pair, the x value 5, the y value 1. If we graphed these two lines, they would cross in quadrant 1 at the point 5, 1. So that's your first experience with substitution. Let's do a couple more of these. I've got one that I just worked and left at work, so you could look at that as you study your video. All right, so here's another system of equations, and again, you'll notice that in the second equation, the x is already isolated, so again that makes it a very good candidate for substitution. So I'm going to take this y plus 1, which is equivalent to x. I'm going to bring it over here into the other equation. So you always have to incorporate from one equation into another equation. Just be careful that you're using both equations. So here's the 2, leave the space for x, minus y equals 9, and right in here we're going to replace x with y plus 1. So there again is my substitution from equation 2 into equation 1. Do a little distribution there. Make sure as we work we understand left side, right side. I see a couple of like terms here. A 2y minus y leaves a positive 1y. And subtracting 2 from both sides, again I have one of the pieces of the ordered pair. I have the variable y identified to be 7. So then you can take that, I'm going into equation number 2 because it looks easier to me. I'm leaving a space for the letter y, and in its place I'm substituting 7 because we found back over here that y is equal to 7, which means that x is equal to 8. So we have finished solving and we have our ordered pair. I went ahead and just set up the second one for you. You can see me doing the same kinds of steps, so you can freeze the video for a minute and you can look and see what I did there to solve. Alright, so I wanted to do a word problem with you before we stopped. This is one where the equations are already set up, but we're working our way toward situations where you'll have to set up your own equations and solve. So we've got a situation here where a student bought both a textbook and a calculator, and the total cost was $125. And you'll see here, this is representing x is the cost of the calculator, y is the cost of the textbook, and that total is $125. So there's the first equation coming from that total cost was $125. Right, the second equation says that the calculator cost $25 more than 4 times the cost of the textbook. So here's the 25 more than 4 times the cost of the textbook, and that is equal to the cost of the calculator. So there are 2 equations. So I've separated these out here, and you'll see again that the second equation is already solved explicitly for the letter x. So I'm going back over here, bringing that information and putting it into equation number 1. So this 4y plus 25 is going right in there in place of the variable x. And then again, what we're doing is we're using substitution. Okay, so here's left side, right side. I'm noticing a 4y and a 1y. That's going to combine to give me 5y. And then I'll subtract this 25 off of both sides. That's going to leave me 5y equals 100. And dividing, I get 20. All right, so what does that tell me? It tells me the cost of the textbook is 20. Why? I haven't seen any textbook that cost $20 in quite a while. And then to come back and get x, I'll go over here to equation number 2, remove the y, substitute in with the 20, and so that tells me that the cost of the calculator was 105. And then you can see that those numbers, if you tried to graph those, would be pretty large numbers to be working with on a grid. So, you know, this is a great way to solve when graphing is not a good option. And of course, if you want to check this, it said that the sum of these two things should be 125, and I think you can see pretty easily. And then it said that the cost of the, let me get it right, the calculator cost 25 more than 4 times the cost of the textbook. And so when you plug those numbers in, you'll see that everything balances out, and you can check and make sure that you have everything right. So that's a good place to stop. There's something new I want to show you in this next section.